Right, so moving on, question number 28. A reaction C2H4 plus 3O2 gives CO2 and water molecules in the 2:2 ratio. So it occurs in a rigid container, closed container at a given temperature. After a certain time, it was found that the rate of the reaction with respect to the consumption of C2H4 was X. So the rate with respect to C2H4 is equal to X. Which of the following shows the rates consumption of O2, CO2 and H2O? Okay, so they're asking the rate with respect to the other components, right? So the easiest way to do this is equalize all these rates and write down the rates of O2, CO2 and water in terms of this X. That's the easiest way. So if you remember, for the reactants, we write down the rate in the negative form because they are consuming. So D, the difference in concentration of C2H4 gas concentration at a certain time rate would be equal to minus, again oxygen is consuming, so DO2 concentration over dt, but you remember we put the reciprocal of the reciprocal of the this stoichiometry. If you want to equalize two rates, we get the reciprocal of the stoichiometry. Right. In the similar way, we can write down the rate for the CO2 and water. So here then it will be positive because they are formed as products. So it will be D CO2 over dt, and stoichiometry is 1/2 equals plus 1/2 D water concentration over dt. Okay, so these are very simple things. And here we know this first, that is given as X, right? That would be equal to 1/3 times the oxygen consumption. So we will take this as Y. Oxygen consumption, we will take this as Y. So Y would be equal to 3x. So the consumption of oxygen would be equal to 3x. And in the similar way, if this is X, and we will take this as Z for an example. So Z would be equal to 2 times X. And here it is in the same way. So the answer is very straightforward. Okay. So I see this type of question after a long time.